Sit here on my couch. Let's talk for a while. I want you, you need me. That's what I call chemistry, 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 chemistry. Me, chemistry, chemistry. I want you, I want you, I
Hello guys, I just hope you are enjoying your holiday. At this point in time, I am going to teach you using a video. You just cooperate, take note of the important concepts I'm going to explain so that when you open, I'll just give you the first 40 minutes of our first period we are going to have so that you can ask me questions on some of the doubted points we are going to have as we are going to be learning through a video. Without wasting a lot of time, guys, we need to go into our educational business. This is chemistry. This is chemistry, guys. And we are discussing a topic known as mole concept. Under mole concept, guys, we discussed a lot of concepts. I told you in a class that this topic is all about having concept, more especially on the application of moles. Moles are very important under this topic. Once you understand how to treat moles in calculations, how to use number of moles in calculations, you'll be okay with the topic. That's the reason why this topic is known as mole concept. Now, going forward, you guys, you remember that we did one of the concepts under the subtopic molar mass and relative formula mass. I showed you guys on how to calculate the number of moles of the substance, how to differentiate between the molar mass and the relative formula mass or molecular mass. On the subtopic we are going to be discussing in this video, depending on where we ended, it demands us to remember the concept on how to calculate the number of moles. So to begin with, I am going to give you a question just to remind you on how to calculate the number of moles. So the question is, calculate the molar mass of calcium carbonate. we are talking about the molar mass of calcium carbonate. This recap, guys, is very important on the new subtopic we are going to do today. Now, what is the procedure, guys? I told you that if the chemical formula is not given to you, the chemical formula of the compound is not given to you, it is very important, guys, that you write the chemical formula of the compound in question. And in this case, the formula of calcium carbonate, guys, is like this. Calcium carbonate. Now, how do we find the molar mass of calcium carbonate? Remember, guys, we said the symbol for molar mass is presented like that in capital letters, and then we say equals. We count the number of calcium atoms in calcium carbonate. You find that we just have one atom of calcium, so we are going to say 1 times the molar atomic mass of calcium, which is 40. Plus, we have one atom of carbon, so we are going to say 1 times 12, which is the atomic mass of calcium, and then we say plus. Oxygen, we have 3 atoms of oxygen times 16. We multiply, we are going to get 1 times 40, we will get 40, plus 12, plus 48, where the total molar mass will be equal to 100 grams per mole. Remember, we said molar mass as units, while relative formula mass has no units. So what is the interpretation of the units here? When we say grams per mole, what does it mean? It means if the magnitude of the molar mass is 100, it means in 1 mole of a compound calcium carbonate, we have 100 grams of calcium carbonate. This relationship, my people, is very important. If we have 1 mole of calcium carbonate, it means we have 100 grams of calcium carbonate. This is the information we need to have in our hands so that we find it easier to succeed on our new subtopic we are going to discuss in this video. The new subtopic, guys, under more concept we are going to do in this video is known as calculating the percentage composition by mass of atoms in a given compound. So the subtopic is known as percentage composition, where we'll be dealing with the calculations depending on the compounds we are going to meet in our lesson today. Going forward, guys, we are going to go back to our slides I have prepared for you so that we can successfully learn our subtopic. I told you that I will prepare the notes and then I will also prepare a video which you are going to watch, and when you watch the video you should be able to understand the concepts. After understanding the concept, guys, you find time now to copy all the notes under the subtopic percentage composition. Now, percentage composition by mass of atoms in a given element involved in the formation of the compound, we have certain learning outcomes. At the end of this video, when you watch it successfully, you should be able to define percentage composition by mass of the elements in the given compound. Point number 2, you should be able to calculate the percentage of atoms in the given compound. Now, when we say percentage composition, what does it mean, my learners? By definition, we say percentage composition is the contribution by mass of one atom of an element to the total mass of a compound. We need to understand the science behind the definition. That is science. Science is all about understanding what we are talking about. The contribution by mass of one atom of an element to the total mass of the compound. We are talking about mass, that is a quantity. We are also talking about one atom, meaning we are saying this atom is going to have mass. This atom is going to be present in elements. And in compounds, we are going to have atoms. And for us to have atoms of the same kind are grouped together to form an element. That's the reason why, my dear learners, we define an atom as the smallest particle of an element that can take part in the chemical reaction. Now, since an atom can take part in the chemical reaction, atoms are able to give us compounds. Now, that compound which is going to be formed is going to have a particular mass. And what is going to determine the quantity or the mass of that compound is the amount of atoms that are going to be involved in the formation of that compound. For example, when we are looking at the compound calcium carbonate, will have how many elements? It is going to have 3 elements. We have the element calcium, we have the element carbon, we have the element oxygen. This is what we are talking about when we say element. Now, we are not going to forget that an element is not going to react. What is going to react is atoms in that element. Therefore, we are also saying we have atoms in a compound. In this case, we are going to say we have one atom of calcium, and then we have one atom of carbon, and then we have 3 atoms of oxygen in this compound. Now the question will be, what is the contribution by mass of one atom of calcium to the total mass of calcium carbonate? This is what we are discussing in this video. And that mass should be expressed as a percentage. That's the reason why we are saying percentage by mass. Meaning we are going to have mass, that mass is going to be converted to percentage. Looking at your capabilities, guys, I don't think you are going to be facing challenges on how to calculate the percentage composition. Now, there's a formula which is used to calculate the percentage composition. And I am going to explain this formula very well when I'll be looking at an example just in a moment. So the formula is percentage by mass equals number of atoms of elements times the average atomic mass of the same element over the total molar mass of the compound. There are steps you are supposed to understand when we are calculating the percentage composition by mass of atoms in the given compound. Now, the first step is that you should be able to write down the formula of the compound if at all the formula is not given to you. So we are saying write down the formula of the compound. From there, you should be able to use the relative atomic mass to work out the formula mass of a compound. When we say the formula mass, what are we talking about? This is the molar mass. That's the reason why my recap involved the calculations of the molar mass of the compound calcium carbonate, so that I remind you on how to calculate the formula mass. When we say the formula mass, we are talking about the molar mass if we are to include units. But when we say relative formula mass, the procedure is just the same. You remember, guys, what we are doing in class? The procedure is going to be the same, only that we are not going to put units at the end of our calculation. But when we are talking about molar mass, we are talking about the mass of 1 mole of a given compound. Therefore, we are supposed to put units. From there, we are saying write the mass of the element you want as a fraction of total. You need to multiply the fraction by 100 to give the percentage, meaning the mass is going to be converted to a percentage, as you are going to observe in my example number 1. Example: find the percentage by mass of calcium in calcium carbonate. The first step we are going to undertake is that of writing the chemical formula of calcium carbonate. The chemical formula of calcium carbonate, guys, is like this. The second step is to calculate the total number of atoms in this calcium carbonate so that we can come up with the molar mass. So we are going to calculate the molar mass of calcium carbonate. So, as I told you in the beginning, we said molar mass equals, we have 1 atom of calcium, so 1 times the atomic mass of calcium is 40, so we are going to say times 40 plus 1 times 12, we are going to get the value later, and then we say 3 atoms times 16. Molar mass, we have 40 plus 12 plus 48. The molar mass of calcium carbonate is 100 grams per mole. Now, since we have 1 mole of calcium carbonate, it means we have 100 grams. of calcium carbonate. If that is not enough to you, you want to believe it that indeed what we are talking about is true, you can prove it by using the formula. We said when we are looking for mass, we said mass equals number of moles times molar mass. So we are going to say mass equals number of moles. We are saying we just have 1 mole of calcium carbonate times 100 grams per mole of calcium carbonate. The more and the more we go, we are going to remain with mass equals 100 grams. This is what we are talking about. So when we have 1 mole of calcium carbonate, we are going to have 100 grams in that calcium carbonate. Now, the question is saying, calculate or find the percentage by mass of calcium in calcium carbonate. We have calculated the mass of calcium carbonate to be 100 grams, meaning the mass of calcium is here. It will be 40 because we said we just have one atom of calcium times the atomic mass, which is 40. When you multiply, we are going to find 40 grams per mole. Now, when we say 40 grams per mole, it means we have 40 grams in 1 mole. Therefore, to calculate the percentage, to convert this 40 to percentage, we are going to say mass, the percentage by mass of calcium will be equal to 40 grams over 100 grams times 100%. The 100 and the 100 will go, will remain with the percentage. The mass and the mass will go, will remain with 40. So we'll say 40 times 1%, it will be 40%. So the percentage by mass of calcium in calcium carbonate is 40%. This is the answer. I just hope we are moving together, guys. If you are going to have questions on what we are doing today, you'll be free to ask me questions when you report back to school after 2 weeks. Okay, we continue. Question number 2. Calculate the percentage by mass of each element present in sodium carbonate. Here the equation, or should I say the formula is given to us. So we are not going to suffer. We will just find it easier for us to calculate the molar mass, and when we calculate the molar mass, that will indicate the mass of sodium carbonate. The same procedure, guys. We are going to find the molar mass of sodium carbonate. Sodium carbonate is like this. So we are going to say molar mass equals, we have 2 atoms of sodium, so we are going to say 2 times the atomic mass of sodium is 23 plus we have carbon there, just 1 atom, so we'll say 1 times the atomic mass is 12, so we are going to say times 12 plus oxygen, we have 3 atoms times 16. So we are going to say molar mass equals For sodium, we are going to have 46 plus we have 12 plus we have 48. Don't forget that what we have gotten here, guys, indicates the masses of each element or each atom in the compound. And then when we find the total, we are going to arrive at the answer 106 grams per mole. This is the molar mass, meaning 1 mole of sodium carbonate will contain 106 grams. Meaning the mass of each element, when we are talking about 2 sodium atoms, it is going to be 46 grams, and then carbon 12 grams, and then 3 atoms of oxygen will have the mass of 48 grams, since it is grams per mole. I just hope you get the concept, guys. Now, we have 106 as the total mass of sodium carbonate. Then from here, we are going to say, okay, now the question is easy. They want us to come up with the total percentages of each element in sodium carbonate. So we are going to start with the first element, which is sodium. So sodium, the percentage by mass of sodium, we are going to say the mass of sodium was 46 grams. Over the total of sodium carbonate, which is 106, times 100%, where our final answer is going to be 43.40%. We have converted sodium, the mass of sodium, to percentage. Then we go to carbon. Carbon, we are going to say carbon equals, we have 12 as the mass over 106 grams times 100%, guys, where our final answer is going to be 11. Use your calculators, guys, to confirm the answers. 11.32%. And then we are going to do the last one, which is oxygen. So oxygen, it was 48 grams over 106 grams times 100%, where the answer is going to be 45.28. Means we have answered the question. And when you add the calculated percentages of sodium, carbon, and oxygen, you should be able to get 100%. Interesting. Going forward, we have an interesting question looking trick, but you are going to solve it, because I know you guys, you are very intelligent, and I have no doubt you managed to do it. The question reads, Epsom salt as the formula magnesium sulfate dot X water. Its relative formula mass is 246. Calculate A, its molar mass. Remember guys, the way I started my lesson, I showed you how to calculate the molar mass. Meaning, I just hope you have that concept, and we have been calculating the molar mass, but we need to start this question now critically because we are having X in the chemical formula of magnesium sulfate. Looking at what we covered under acids, bases, and salts, guys, you understand that when you see a salt is having the certain amount of water in its crystal, that salt is going to be called an hydrated salt. Now, to interpret this equation, we are saying we don't know the number of moles of water in magnesium sulfate crystals. Therefore, the value of X is not known. Since the value of X is not known, it is not possible that we can calculate the molar mass of magnesium sulfate. So this is just an application question, guys, where you just needed to reason, looking at the relationship between molar mass and relative formula mass. I explained in a class that relative formula mass is calculated in the same way we calculate molar mass, only that only that the relative formula mass or molecular mass is not going to have units, as you can witness in this question. The value 246 is not having units. But when we calculate the relative formula mass or the molar mass of the same compound, the magnitude is going to be the same, only that the relative formula mass will have no units, while the molar mass will have units. So here, there's no need of you start panicking. It's just a matter of giving the same answer, but you include what? Units. So here, the molar mass of this Epsom salt is 246 grams per mole, because the question is saying molar mass. Molar mass, there must be units. Interesting, guys. So it is just an application question where you need to analyze the question and relate. Interesting, guys. Going forward, now they are saying calculate the value of X. What is the value of X? Remember, the compound is magnesium sulfate X water. Now we are looking for the value of X. And this X is representing the number of moles of water in the magnesium sulfate crystal. When you go back, you remember that I explained hydrated salts, and indeed they were numbers where we have put X today. Maybe 5 moles of water, 7 moles of water, 10 moles of water. Now, today, this is more concept. The question is for us to calculate and find the value of x. It is very simple. We are going to start. Remember the procedure we use when we are calculating the molar mass. That's the same procedure we are going to use now. So we are going to say molar mass of magnesium sulfate, an hydrated salt, equals, we have 1 mole of magnesium, so we are going to say 1 times the molar mass of the molar atomic mass of magnesium is 24. So we'll say the atomic mass 24 plus sulfur. We just have 1 atom of sulfur, so we'll say 1 times the atomic mass of sulfur is 32 plus. Then oxygen, we have 4 atoms, so we are going to say 4 times 16 plus. We have X, and this X is affecting hydrogen as well as oxygen. So in this case, it's same as we are having 2x, and then we have x there. That's the meaning. Because this x is affecting the number of atoms in the compound water. So we are going to say we have how many atoms of hydrogen in this compound? We have 2x. And the atomic mass of hydrogen is 1, so we are going to say times 1 plus. We have x atoms of oxygen times 16. We have formed an equation. Now, the molar mass we have calculated here is 246. So we are going to say, where we have mm, we are going to put the molar mass. So the molar mass here is 246 equals 1 times 24, will have 24 plus 32 plus 64 plus 2x plus 16x. When we add everything this side, we are going to say 246 equals, when we add everything, we are going to have 120. 120 plus 18x. We collect the like terms. We are going to transpose 120. So we are going to have 246 minus 120 equals 18x. When we subtract 120 from 246, our final answer will be 126. So we'll say 126 equals 18x. We are looking for x over 18 over 18. And the value of x now will be x equals 7 moles of water. So we have calculated the value of x, and the value of x now is 7. Therefore, we can put That's 7 in our structure, where we are going to say magnesium sulfate dot 7 water. At this point now, we can even name the compound because we know the value of X. And the name of this compound is magnesium heptahydrate. Magnesium heptahydrate. Where is that hepta coming from? It is coming from the value 7. Hepta means 7. And hydrate is coming from water. When I say your body is hydrated, it means you are having a lot of water in your body. So that is the chemical language, guys. Interesting. We do see. Calculate the percentage of water of crystallization in the salt crystal. So we are having the same compound, which is magnesium sulfate 7 water. Now we want to convert the mass of water of crystallization to a percentage. The same concept, guys. So in this salt, we have 7 moles of water, and when you calculate the molar mass of water, you are going to say water, we have 2 times 1 plus 1 times 16, that of oxygen. So we are going to say the molar mass of water will be 2 plus 16, which will be 18. This will be grams per mole. So converting this 18 grams per mole to mass, we are going to say mass equals number of moles times molar mass, where we'll say mass equals the number of moles of water in this salt. This salt is 7 moles times the molar mass of water. Just 1 mole of water is 18 grams per mole. So we are going to say the mass will be equal to the value. When you calculate there, you find 126 grams. So you are supposed to convert this 126 grams to percentage so that you can answer the question C. So what are we going to do? We are going to say the percentage of water in this salt will be equal to the mass, which we have calculated to be 126 grams, over the total mass, which we calculated 246, because we said 246 grams per mole. So it means in 1 mole we have 246. So it will be 246 grams per mole times I am not going, just pardon me. We have converted it to mass, so we are not supposed to say per mole, so it's just 246 grams times 100%. So the mass and the mass will go, where our total percentage now will be 51.22%. This is the answer. So what is important, guys, is just to have a concept, as the topic itself alluded to, because it is more concept. So you should have a concept. Once you understand the concept, guys, you are going to be enjoying the topic. At the end of the day, you'll be enjoying chemistry. Therefore, I encourage you guys to watch this video, understand. If you are going to have questions, maybe one or two, I'll give you time to ask me questions when you open after 2 weeks. I am having an exercise, guys. This exercise is also there in the notes I sent to you to copy. Make sure that you copy the examples I have solved in the book. You also write this exercise, and the instruction is that you submit your work in the first lesson we are going to have in September. So find time, guys. Let us cooperate. We save time. We finish all the topics in grade 11, so that we can have ample time to go through past papers and prepare for exams effectively. For now, I am going to say thank you, and you guys take care. Remember to revise. If you are revising, you are going to be wise, because you need to be using your time very well. Thank you so much, and I appreciate, because I know you are not going to disappoint me. You are going to follow my instructions. Thank you so much.